You might say we're living in an extraordinary time. It's a whole new world on the brink of a new era of possibility. It's all here. We just need to look around. A world where self-driving cars take us safely where we want to go. A world where we can fabricate custom solutions right where they're needed, and to fantastic result. And even redefine possibility, where we can send robot photographers to visit faraway planets and learn more about our far-flung universe. All of these advances are brought to you by, enabled by, and reliant upon data. We are living in an extraordinary time, a time when we not only can imagine a whole new world, we get to help build it.
Ladies and gentlemen, please welcome back Roger Anderson.
All right. Thank you. Day 3. I hope you're ready. You know, if anyone here is not thoroughly enjoying yourselves, you're really keeping it a secret. I'm having a blast. And I want to ask you a question, but before you answer, I want you to think about the sessions you've been to, the general sessions we've had so far, money you won in the casino, dinners you've had, with friends and conversations. So my question is, have you had a good time this week? All right, that's great to hear. Now, that wasn't as loud as what the Jeff and Nito show got, but I didn't expect it to be. In fact, yesterday, I think the Nito love meter got pegged. All right, so as if yesterday's demo wasn't enough excitement, today we'll be sharing some of the new stuff we've been working on. So more to come on that later. Before we start the program, to our customers and partners who gave us feedback on how to accelerate our flash sales, thank you. We listened and we made some changes. We made 40% pricing and form factor reductions. There's a new 7-year warranty, and there's a free controller upgrade program for customers on premium support. So I hope that's good news. Details are on our website. Really the success of these changes has made All Flash Fast one of the fastest growing products in NetApp history. So thank you. All right, now I mentioned yesterday, and I think you saw it coming in here, today is a special day. It's Certified User Day. Congratulations to all of you who are now officially NetApp certified. Just today, as of yesterday end of day, we had over 250 people certified on site. So appreciate the dedication there. Also, a big thank you to NetApp U. You can get together with other certified folks at 5:15 today for the special Greet and Geek event. So be there for that. I'm actually not sure what to expect, but it sounds like fun. So also another highlight for Insight has been our hands-on labs. So hands-on labs is an opportunity for attendees to get hands-on experience on NetApp and partner solutions. As of yesterday, over 1,000 labs had been completed, over 60% of those by customers. So to our customers, really thank you for taking the opportunity. I'm sure there's a lot more of that happening today as well. And then really exciting to hear is that the top 5 labs were 8.3.1, WFA, 7MTT, so a lot of folks interested, how do I use 7MTT to transition from 7 mode to cluster data ONTAP? OCI, another big one, that's great. And then the advanced cluster data ONTAP lab. So coming up later in the program, we're gonna have the incomparable founder of NetApp, Dave Hitz. He's gonna share his thoughts on the next big trends and why NetApp is positioned so well for tomorrow. But before that, we have a special guest. So it's my privilege to introduce our first guest speaker today. He's not a NetApp exec, he's not a NetApp sponsor, he's not a go-to-market sponsor, he's not a NetApp employee. He's a physicist, and he's the former editor-in-chief of Wired magazine. Prior to Wired, he was with The Economist for 7 years. He's been at the forefront of the drone revolution. In fact, he founded DIYdrones.com and co-founded 3D Robotics. So he's here to tell us the somewhat unlikely story of how all that came about and how it is impacting the world of data. Please join me in welcoming Chris Anderson.
Thank you. So as he said, I'm going to tell you a somewhat unlikely story of why I'm here. But the big reason is you may be asking, what's going to fill all this storage? Where's the big data, the next big wave of big data going to come from? And you may have heard that it's going to come from the Internet of Things, of digitizing the planet, et cetera. And you may ask, well, why are we talking about this now? Why is the Internet of Things a thing right now? And so what I'm going to do is I'm going to tell you a story. As you heard, 2.5 years ago, I was a magazine editor. And now I run the biggest drone company in America, and that should not be possible. And so what I'll do is I'll explain why that's possible, why lots of people are doing things like this, and what this means for this next wave of big data. So it all started in 2007. 2007 was the year that hardware got hot. It was the year that hardware started to become like software. It was the year that everybody out there who was kind of paying attention to these leading edge trends sort of felt this glitch in the matrix, this kind of signal that went out in the ether, and they said, wait, there's something going on with hardware. Now, for some people, it was the guys who did the Fitbit wearable, it was a Wii controller. They got a Wii, the Wii controller had some sensor in it, accelerometer, and they were like, what else could we do? And they came up with a wearable. For some other people, it was 3D printing. For some people, it was like the Arduino open source computing platform. So for some people, it was the maker movement, Make Magazine, Maker Faire. For me and my kids, it was Lego Mindstorms. Lego Mindstorms came out, NXT came out that year, and you could buy a toy with these really cool sensors in it, these gyroscopes and accelerometers, magnetometers, ARM processor, et cetera. And unfortunately, my kids were completely bored by Lego and bored by the wheeled robot they wanted to, that was in the instructions, and they said, what would be cooler than that? And we thought it might be cool if the robot could fly. So we literally Googled flying robot. The first result was drone. We Googled drone. The first result was autopilot. And then we Googled autopilot, and there was a lot of math. So we sort of stopped Googling. And we said, we just did it. And so here it is. This is the world's first Lego autopilot. That's a Lego Mindstorms controller with the sensors attached to it, and it's running. I Googled some algorithms, and we had 9-year-olds write them, and stuck it in an airplane. And that airplane it flew, and it almost flew autonomously. And my children thought that was enough and went off to do other things. And I got chills. It should not be possible for a dad and his kids on the dining room table to build a Lego unmanned aerial vehicle. And that is, by the way, the world's first Lego drone. It's now in the Lego Museum in Billund, Denmark. And I just had to learn more. So I started a community, called DIY Drones. The community started designing things together in open source models. And then the next generation of people came in and they said, well, can we just buy it? Can we buy this drone from you? And so I decided that I needed to sell a kit. So this is our first production line. That's a couple lessons there. You can see we pay the workers with strawberries and juice. Don't put the 6-year-old on quality control. This is what we were making. It is a Blimpduino, an autonomous blimp kit. That is a pizza box. It worked all day, putting it together, sold out in 10 minutes, and then I said, great news, kids, we have to make more. And they were like, no way, we're done. So I went to the community and I said, anybody there want to help me make robot blimps? And This guy here named Jordi Munoz said yes, and he sent me a picture of him. He was, I didn't know where he was, but he sent me a picture of him in his garage, and here he was soldering boards. And I thought, hooray, someone's going to do this for me. That's terrific. And then he sent me more pictures, and he said, I've got a little shop. And I thought to myself, he's got shelves. That is completely pro. So how impressive. And then he sent me another picture, and he said, we've got a bigger shop. And it turned out that he'd gone on eBay and bought pick-and-place machines and reflow ovens and stencil printers and CNC machines. And I'm like Googling very quickly to find out what these things are. And I'm like, what's going on here? So I went down to meet him, and it turns out that the guy I'd accidentally started a company with was a 19-year-old in Tijuana, Mexico, who had just just graduated from high school, hadn't gone to college, and was just available. And it turns out that if you're going to start a 21st century aerospace company by mistake, you want to do it with a 19-year-old from Tijuana, because they know three amazing things. Number one, they're 19, so they're just kind of like, they're completely immersed in modern technology. He turned me on to Arduino. He knew what a pick-and-place machine was. He understood the trends of technology in a way that only 19-year-olds can. Number two, he was completely fearless. He didn't realize you're not supposed to be able to buy used manufacturing equipment on eBay and download the manual from Google and just teach yourself how to build a factory. He just did it. And number three, because he lived in Tijuana, building factories was like second nature. It is quite literally in the air and in the water. And this is what, this is the Shenzhen of North America, and this is where factories are. They are all in Tijuana. I know that people think of Tijuana as, cheap tequila and drug gangs, but what it really is where most electronics are made in North America. And, when you're going to start a social network, pick a guy from Harvard, like Mark Zuckerberg. When you're going to start a factory making the Internet of Things, pick a teenager from Tijuana. So that was lucky. And it kept going. And he kept sending me more pictures. He said, here's our new facility in Mexico. This is the clean room. The picture, I was impressed by this because the woman who's running the pick-and-place machine right there is wearing a smock with our logo on it. We kind of drew a logo, and she's wearing a smock. And she's also connected to the machine with something called an ESD cable, which is basically she's grounded to the machine so you don't have electrostatic discharge. And I tweeted this picture because I was so proud of the smock, and people noticed the cable, and they're like, you chain your workers to the machines? Capitalists. And then the factory got bigger and bigger and bigger, and at this point I quit my job. I'm like, okay, I don't know what just happened here, but somehow by accident we created a Tijuana drone factory, which by the way is a great name for a band. And so we created Tijuana Drone Factory. It was actually, we were selling a lot of them. It's incredibly advanced. The community was doing the open source development. The factory was doing the hardware. And I'm like, this is a thing. Somehow, what was going on in that 2007 to 2012, 13 timeframe was the birth of this new hardware renaissance. And you didn't need to be a big company. You didn't need a lot of venture capital. You didn't need to be skilled in these things. That it was a moment where the technology had gotten easy. And so if you look back at what was the real enabler in 2007, it wasn't any of those things I described. It wasn't, they were all helpful, the 3D printing, the Arduino, et cetera. But the real enabler was the other big thing that came out in 2007, which was the iPhone. This turns out, the Internet of Things is basically a spin-off of the smartphone industry. That the reason that people like me can make advanced drones is because it got easy. And it got easy because of the MEMS sensors and the ARM processors and the wireless and the cameras and the GPS and all that stuff that's now made in the hundreds of millions by the Apples and the LGs and the Samsungs of the world. Those components in smartphones are advancing faster than Moore's Law has ever worked in history. The speed at which those components are getting better and cheaper, faster than the PC, faster than the internet, faster than ever before in history. And those components are now transforming industries adjacent to the smartphone. For us, robotics was one, but wearables is another, Internet of Things, sensors in general. We're just starting to see what we call the peace dividend of the smartphone wars, which is that suddenly hardware's getting out there, it's smart, it's got sensors, and it's connected to the internet, and it's all gathering big data. So today, I quit my job, we did raise venture capital, and today we make more drones every week than the entire US aerospace industry combined, which is nuts. And yet it's also exactly right, because the aerospace industry thought that drones were airplanes without a pilot, and we realized that drones were smartphones with propellers. And we sell the most advanced drones in the world in Walmart, and that's because the users are unsophisticated. The military was built around the notions of pilots and operators and training and checklists and mil-spec, and we were built around the notion of press a button and magic happens. And when you press a button and magic happens, there has to be a lot of intelligence in that thing. It needs to be truly autonomous. Machine learning, AI, computer vision, all this really hard stuff is necessary to make something easy and simple so that you don't need training. So by simply taking competency out of the equation so that regular people can do it, the technology had to be more advanced, and because it was more advanced, it was accelerating faster and could do more things, and so we got this bottoms-up revolution in autonomous vehicles. So what happened is we did this when we inherited this notion of smartphones with propellers. Some things came with this. First of all, the notion that, of course, a smartphone is part of the equation. So we started with the flying robot, but then the flying robot was connected to a phone. But then, of course, the moment you're connected to a phone, you're also connected to the cloud. And then what you realize is you have this stack. You have this full stack from drone to phone to cloud. And that computation is happening at all three levels of the stack, and you have different amounts of compute available at each layer with different latency. So the drones have limited compute with low latency, phones have more compute, more latency, and the cloud has infinite compute with more latency. But you can now load balance across these three levels of the stack and do things that no one of them could have done on their own. And so by coming at this, we ended up with our consumer drone, the Solo, which is exactly that. This is a node on the internet. This is the Internet of Things, it just doesn't look like it. It's connected to the phone, and it's connected to the cloud, and it's got onboard Linux processors, and more Linux processors in your phone, and more Linux processors in the cloud, and you can run the same code at any layer of that stack. And this means that we now have the ability to do smarter things than the device itself could do. The great thing about the Internet of Things is that the intelligence is not in the thing. It's in the internet. The thing might just be a sensor or an actuator. And the intelligence can reside in the cloud where it gets better and smarter all the time. And because they're all connected, it learns collectively over the entire fleet. And we now do machine learning across thousands of these things as they data log in real time more than a 747. Each one of these is data logging more data than a commercial jet, and we're getting it in real time, and we're managing across the whole fleet and then pushing out updates and tuning like a Tesla. These things get better every day. And that's how this virtuous cycle of things connected to the internet starts to change the industry. So what I wanted to talk about is what are we doing with these things? Now that we've got these sensors in the sky, now that we have the ability to break the connection between man and machine so that rather than one pilot, one plane, we now have one operator, thousands of drones. Or maybe no operators, thousands of drones. Maybe these things are just sort of out there doing their own thing. What is that thing? So when I was a kid, my favorite book was this one by Flannery O'Connor, Everything That Rises Must Converge. It's a collection of short stories. But the book is fine, but what I loved is the title. Everything that rises must converge. And so you ask yourself, what are the big technology trends here? And how are they converging? And what we ended up was this. We realized that drones and smartphones were really the two sides of the same coin. And that, of course, Linux was another mega trend there was also part of this. Now the processors, because we're using smartphone processors, they have the power to run Linux. And once you run Linux, then all this other stuff, these big data tools, computer vision, these kind of AI algorithms, they come for free because there's a huge Linux community already doing it. And now things that were prototyped in universities and prototyped in big data cloud facilities, you can now run them on smartphone-grade electronics. So suddenly we realized we're part of that movement as well. And then there's something called a Robot Operating System, ROS, which was the kind of where the academics have been doing the really bleeding edge work on autonomy. And now that was based on Linux, and now that can also run on these vehicles. And so we realized that we were right at the center of these converging trends. And by realizing that we're not part of the aerospace industry, and we're not just part of the of Hollywood, but rather we're part of this bigger movement towards extending compute and data into everything, then we're able to make choices that allow us to do more than any one company could do on their own. So this is some of the stuff we're doing. This is a little video that is a glimpse of the early stages of what we call reality capture. This is when you take pictures of things and you know the location of those pictures, you're able to stitch together the imagery and create 3D models. Now this is not a great 3D model, but I want to show you a little bit how we make it better. So here's an example of the Fry's in San Jose. And this is just with a GoPro camera and a drone. And you can scan a building. Now, how would you scan a building normally? There is no way. You can't get up that high, can't get around it, etc. But a drone can do it easily. It orbits around it, it takes pictures at the right intervals, and then it sends those pictures up to the cloud to be stitched. Now, for these structures, which are simple structures, it's fine. But what if you take a really complex structure, a really messy structure like this cement plant? As you can see, things start to fall apart a little bit. Why do they fall apart? The answer is that we're guessing at what the algorithm wants. We're guessing at the imagery necessary to capture the world precisely. Well, why are we guessing? This is what in robotics is called an open loop problem. And this is when you actuate and then you get no feedback. But the things work best when you do get feedback, when you can close the loop. So if any of you have an Android phone, you probably see on the Google app, there's something, in the camera app, there's this 360 spherical feature. And the way you take pictures is that you start with a picture and then it guides you to the next picture the algorithm wants. And there's this dot and you kind of move and you put the dot in the circle. And it guides you into getting the imagery that the algorithm wants so that it can stitch together a perfect sphere. So that's a closed loop system. It's measuring, it gathers the data, it analyzes the data, and then it guides you to getting the next data. So how do we close the loop on something like drones? And the answer is that the drone is talking to the cloud. The drone is gathering an image, sending it to the cloud. The cloud says, got it. Okay, here's the next image I need. Sends the drone to that place. The drone gathers that image. The cloud says, turns out that that the shadows or the lighting has changed. We need to change the settings on your camera to get the right image. And it does that. And by this real-time feedback loop, we're able to get better data and more predictable data. So we still have one last problem, which is let's make sure we don't hit anything while we're doing this. And so we still have a human in the loop, but now the human in the loop right there, who is me, is just walking around a building. And the drone is going up and down and gathering the imagery based on this communications to the cloud. And my job as a human is simply to use my body as the controller and to look up and make sure that there's no birds or telephone lines or trees in the way. So this is what we've taken piloting down to, walking around a building. That's it. And this would be on a construction site, and your job is really just to kind of, like a dog on a leash, or I guess a bird on a leash, walk around the building and make sure that there's no weird obstacles in the way. That's what the humans have been reduced to, walking around buildings. And when you do that, you get much better imagery. So this is that very building I was walking around, and you can see we've now gotten to the point we can look at the details underneath it. It doesn't fall apart as much. And this is still just the beginnings of this. So this is an example of a kind of a robot-human interaction, where the humans do what humans do best, which is safety and judgment, and the robots do what robots do best, which is gathering data and talking to the cloud. So that's one example of how we're applying it. That happens to be construction. But I want to give you another one. This is an example of endangered species conservation. This is completely, again, when you're digitizing the world, you never know what the applications are going to be. And this one kind of came out of nowhere for us. It turns out that chimpanzees and other great apes are endangered, and it's very hard to count them without disturbing them. They live in trees. You don't want to rustle the trees, et cetera. But the one way to count them is with their nests. Every night, chimpanzees and orangutans build a new nest, and you can spot the nest from the air. Even though you can't spot the animal, you can spot the nest. And it turns out that those nests decay over about 30 days in a very predictable way based on the weather. And so you can just apply this chimpanzee nest decay rate to the observed nests and count the population from that. And this is like really hard to do for humans and really easy to do for drones. So those are nests right there. Come through a few more. Again, a little hard to spot for the human, very easy for computer vision. And let's go up a little further. And once you do an entire range, you can start to spot all the nests, and then you can start to do the population statistics. Those were orangutan nests. These are chimpanzee nests. They look similar, easy to spot as well. So in that instance, they were able to do a population survey. They were able to do a census of an endangered species population without disturbing the population. Impossible to do before and easy with drones. So that's using the camera. What about using the sound? Well, other endangered species are like bats. Now, bats make noise at night, of course, but how can you hear the bat noise over the sound of the drone? And the answer is that they make different sounds. And if you characterize the bat noises from the drone noises, the drone noises are very predictable, the motors, and you're able to cancel those out and detect the bat noises. And so now we can fly over forests and do a population census of bats. And you can do insects, and once you use multispectral stuff, you can start to see things that are only visible, swarms of insects that are only visible in the infrared, and so on. And so this is just like the first minute of the day on using drones in endangered species. And what's great about this is that we had no idea. We just put the drones out there, and people found uses that we never thought of. Here's another one, logging. This is an example of an illegal logging area in Indonesia. And what you may notice is that there's this strip of trees left around the water and the roads. And the way that illegal loggers work is they basically, any place you could drive and see, they leave the trees up there, and they just go in a few trees and they start cutting. And so it's really hard to spot the illegal logging from ground level. But from the air, it's really easy to spot. The problem is that it doesn't take them very long to do this. So if you use satellites to spot this, you'll be too late. So this is an example of what that area looks like. The outside is there from Landsat. That's what a satellite imagery looks like. First of all, it comes by about every 30 days. So by the time you see it, it's too late. And second of all, the resolution is terrible. But the drones have 1 centimeter per pixel resolution, and you can put them up at any point and see them immediately. And so this is an example of where you're able to spot illegal logging in real time for almost no cost. Incredible tool, only really possible from the air. So this is just, again, the first minute of the day. This is the level of reality capture, the level of sort of digitizing the planet we can now do for almost no cost using consumer-grade technology. And the amount of data that these things generate is tremendous. So these drones gather a terabyte of data per hour, and we have millions of them out there. And this is, again, the first minute of the day. So this is a big data explosion. This is the biggest big data movement I've seen. And I just want to sort of put it in broad historical context. In the late 1960s and early 1970s, we had the beginnings of the space race. And a guy named Stuart Brand from the Whole Earth Catalog said to NASA, when can we see the whole Earth? When can we see a picture of the whole Earth? And so NASA created some composites and ultimately took a picture of the whole Earth, and this was it. And for the first time in history, we could see our planet as a planet Not just a visualization, but an actual photograph of our planet. And this led to a real change in the environmental movement. People started thinking less about local air pollution and more about global climate change. And it gave us this holistic, sense of managing the planet as a planet, because we could finally pull back and see it with remote sensing. Well, today, we're doing the exact same thing, but now at much higher resolution. This is what a farm looks like to a drone. What you see here are four circular crops, regular crops, but the one down here has been scanned by a drone, and rather than looking like one crop or one field, because the drone can analyze the spectral characteristics of the imagery, you can see that that one field actually has different kinds of soil, different kinds of water distribution, different kinds of plant distribution. And so it should be managed differently as well. Rather than spraying the whole thing with a one-size-fits-all model, instead, what you do is you break it up into these little cubes, these little sort of, atomic units, and each one then gets a different kind of fertilizer treatment. And the reason these are circles is because there's these big sort of, spraying arms that go around in a circle. The spraying arms have that resolution. Each one of those is a nozzle. And they can actually change the amount of fertilizer, chemicals, pesticides, herbicides, whatever, that they spray at that resolution. And so what we've now done is turning it from a kind of a one-size-fits-all monoculture into precision agriculture. We can now treat the world with the heterogeneity it really has. And so rather than sort of prophylactically spraying chemicals in our food and our environment because we don't know better, we can now know better. We can scan this thing. We can scan it daily. We can scan it for free. We can scan it incredibly high resolution. And we can now close the loop on agriculture, the biggest industry in the world. So where does that leave us? Another historic analogy. In the late 1980s, there was a big debate, and the debate was satellite phones versus cell phones. You could put up 64 satellites, that was the Iridium constellation, and cover the planet. Or you could put up like millions of cell phone towers. Now, it seemed at the time head-slappingly obvious that it makes more sense to put 64 satellites in the sky than millions of the cell phone towers on the ground, and yet it turned out just the other way. And ask yourself, why did cell phones win? Why did cell towers beat satellites? And the answer is that, you can think about things about like, rockets and maybe, maybe the ownership. But the real reason is that the sat phones were phones. They were for voice. And the cell towers were originally for voice, but then very quickly we realized they could do data. And the demand for data was essentially infinite. The cell towers could scale. They could subdivide, the spectrum geographically, physically subdivide the spectrum so they could share it with more devices. It could change technologies to handle. It had to handle wireless data. It had fiber backhaul. It had low latency. And most importantly, you could put capacity where you needed it. Rather than having to cover the whole planet or nothing, you could start with the highest value markets. And so cell towers scaled, and they allowed wireless to move from voice to data and beyond. And now we're seeing the same thing happen with drones. Drones are going to beat satellites the way that cell phone towers beat sat phones, because they scale, because they put capacity where you need it, and because that capacity, we're just at this beginning of the industry, we don't know how much capacity we're going to need, but it's going to be more than we can imagine. You can't do the big data explosion I'm talking about right now. We've had 30 years of the space age. We can't, it's too expensive. We can't get as much data as we want. Even with CubeSats and SpaceX, that's taken 1 order of magnitude out of the cost of remote sensing. Drones take 3 or 4 orders of magnitude out of the cost. That's what I mean by scaling. So in a sense, what we're seeing is a transformation of this digitizing the planet from a kind of a satellites and planes to drones to the inverse. These drones are going to be the new satellites. These drones are going to create orders of magnitude more sensing. And our question as an industry is, what are we going to do with that data? What are the applications? What are the analytical tools? How are we going to store it? How are we going to transmit it? How are we going to visualize it? These are all really interesting questions, and the same thing's happening everywhere else in the Internet of Things. This is just my thing. But once you realize that we're on the cusp of total change in the kind of data we can gather and the cost of gathering it, you prepare yourself for the day when we have to manage that data. So I wanted to end with just like one last example. This is my grandfather, Fred Hauser. He was a Swiss immigrant to Los Angeles. Worked in the early days of Hollywood at MGM, creating the talkies. He's working on these mechanical tape loops, and by day he did that, but by night in Los Angeles they were greening the desert. They were putting in lawns and sprinklers, and it was an amazing thing. But people had to come home at night and turn on their sprinklers. Now, as a Swiss engineer, he was essentially a watchmaker, as I presume as the cliche would have it. And so what he thought is, what if you put a watch on top of a sprinkler? And what you get there is an automatic sprinkler timer. And that's what he did. He invented the automatic sprinkler. So if you have an automatic sprinkler, you have my grandfather to thank. And so what this did for me is it both inspired me with the idea of being an inventor, or being an entrepreneur, or kind of creating something in your workshop. But it also got me thinking about sprinklers. And what I realized is that when you think about drones, think about them like sprinklers. Sprinklers are just these devices you plant and you forget. These devices that kind of are autonomously doing their thing. They're just out there. Yeah, every night they kind of turn on, they spray water, and then they go back into the ground. And I think what you're going to see is, now that we've broken the link between man and machine, now that you don't need an operator for your drones, now that they're autonomous, now they can recharge themselves, now they're connected to the internet, that we should think about robots like sprinklers. They're just out there. They do their own thing. They gather the data. Rather than spraying water out, they get a spray of data in. That data is connected to the internet. And we now have the ability to scale them on a level that we never could with humans. So this is kind of a radical notion. It's not something the aerospace industry would have come up with on their own. Instead, it's what happens when you think about an industry like aerospace from an Internet of Things perspective. When you think super cheap, super autonomous, super easy, always connected, you end up thinking about aerospace like sprinklers, and then forgetting about it, instead thinking about what it's doing. Not what it is, but what it's doing. And what it's doing is digitizing the planet. So here we have it. This is the architecture of the future. This is where my world meets your world. You have a drone. The drone is connected to the cloud, sometimes through a phone, and then our cloud is connected to other clouds. Some of them are hyperscale, cloud providers. Some of them are enterprise clouds. And as far as anyone's concerned out there, if you look at the big industries out there that are going to use this digital data, they don't care about the drones. All they care about is the data. And we've abstracted this. So all they see is that this amazing digital data about the planet is in a cloud, available to their cloud, and it's just APIs talking to APIs with very cheap, very abundant data that is real time, that is on any cadence you want, incredible resolution. We've managed to turn it into something that looks like the internet by simply using the autonomy to abstract away the thing. So everything you're doing out there is now relevant to this. And you may not think you're in the reality capture industry. You may not think you're in the digitizing the planet industry, but I'll bet pretty soon you will be, because we are there on the front lines are making those sensors ubiquitous. We're connecting them, and now get ready for a flood of what comes next. Thank you very much.
All right, Chris, that was fantastic. Super interesting. I'd like to ask you, I have time for one question.
Yeah.
All right, so I'm not sure if you were here on the first day. Our CEO, George Curran, told a story about being in a park with his 8-year-old daughter. She climbed up a tree, went out on the branch so she could look out further. So we don't have a tree, and you're a grown man, but if I asked you to predict the future for drones 5 years out, how would you answer that?
Well, we know smaller, cheaper, lighter. So if you follow the smartphone analogy out, where do smartphones take us? Well, we know that the cameras are getting incredibly good. We know that the processing power is getting good. We know they're starting to be able to do image, computer vision, image analysis. They have more and more sensors. They're better and better connected to the cloud. So if you take that out, what does that mean for a drone? And that means a lot of things we now do that are mechanical, like gimbaling cameras to stabilize them, become digital. A lot of things right now we do with multiple chips become a single chip because we're just built on Snapdragon architectures and things like that. And so basically drones that are now like 2 kilograms and this big become the size of your hand. They go from $1,000 to $100 to $10. That this notion of them being consumer products that you take videos with kind of it becomes trivial compared to the enterprise thing. And you start to darken the skies with sensors.
All right, so everyone in here could own a drone in 5 years.
Or a few hundred.
Or a few hundred. All right, Chris, it's been an extreme pleasure having you here. Great talk, really appreciate it.
Thanks so much.
Thanks very much. All right, so we'll get right to it. It is my ultimate honor to introduce NetApp's very own founder and executive vice president, Dave Hitz.
I recently had an experience that I have only had one time before in the 20 years since NetApp went public. I got a new boss. You guys met George? We have a saying at NetApp, what interests my boss fascinates me. And so I've been watching George. I mean, I've known George for a number of years, but he's in a new role, and he's my boss. And, you get a sense of where someone's focus is. George is good at a lot of things, I mean, naturally, but the thing his passion is getting things done. The art of getting things done. How do you turn an idea into Alex strategy? Okay, that's fine, but make it an action. And it was, when's the result? How do we check it? What's the fault? What metric did you change? It's just really clear to me that George is going to be very focused on that, which I think is going to be healthy for NetApp. And there's actually a corollary to this saying we have. I was telling my staff once, back when I ran engineering, about something the CEO thought was interesting. And one of the guys on my staff said, what interests my boss's boss really clenches up my anus. So speaking of things that make you think hard, this Dell buying EMC thing. So here are some questions I have. This is the largest acquisition in the history of tech. How would you find someone with experience to run something like that? And this talk is about predictions, so I'm going to make my very first prediction right now. They haven't announced it yet, but it's going to be Carly Fiorini. Who else has the background to pull it off? We're talking about predicting the future. In a sense, it's all of our jobs to predict the future, right? I mean, every time you choose a vendor or decide how to deploy something, you're trying to guess how it'll be used and hope that'll work. And so there's a bunch of tools that one can use to do that. One of them is to look for trends. And there's always lots of trends in the computer industry, and some of them we don't even need to do any work to take advantage of. Mobile computing, Internet of Things. Anybody here have a fitness watch, a Fitbit? So anyone with a Fitbit, you're a NetApp customer. The data flies across the internet, lands in a cloud, and goes down to NetApp storage. And we didn't do anything at all. We sold to IBM SoftLayer. That's the cloud that it happens to be. So NetApp is helping you be thin. And there's another one. It's related to the Fitbit. It goes on your ankle. And that's, anybody? And not all of the brands, but one of the brands, the data flies across the internet, up into the cloud, and lands on NetApp gear. We are keeping your neighborhood safe. So there's all these trends, You know how in CIO magazine, there's like a list of the top trends for the year, and then next year there's another list of top trends, and it's a different list? To me, if a trend doesn't last at least 10 years, it's not really a trend. Right? So I think one of the ways to help predict the future is to look for these trends that just go for a long time. And I'll give you an example. A trend like this is 1982, IBM introduced the PC, and it was 10 or 15 years before you could just assume that everybody's desk in business has a PC on it. And it was 30 years before you could assume that every 8-year-old's desk had a PC on it, right? I mean, these are long trends. And when I look at the ones that matter to us right now, I see 3, or 2.5, depending how we count. The first one is flash. Clearly a big, important trend, and actually one that users don't need to worry as much about. If the storage vendors do their job, we make your storage system faster and cheaper and better, whatever, just like computers do all the time. The second trend is more complicated. It is cloud technologies. And what I mean by cloud technologies is the underlying technologies that let us build cloud server virtualization and RESTful interfaces for storage and just all of the whole stack of technologies. And I think that is a very different trend than the cloud business model. Because one is just technology you buy. More technology. I buy a mainframe, PC, Unix, Windows, Linux, cloud technologies. Like, it's just more stuff to buy. The cloud as a business model, for the first time ever, the question is, should I even buy a computer? I don't need to find a place to put it. I don't need to find, it's a completely different thing. Vendors like us can kind of make the flash thing go away. There's no way we can make the cloud business model go away. I don't mean go away that it's not happening, but go away, you don't have to worry about it. The cloud business model, as customers have to think about it and worry about it. So when I look at these big trends, flash, cloud, and of course the old way to store data is disk, it's not a bad way to think about data fabric to just say these 3 things: disk, flash, cloud. How do I get the data to whichever of those is the place I want it? So flash. I'm going to talk about flash and then cloud. When I look at flash, NetApp absolutely nailed the correct flash architecture 5 years ago. We just blew our competitors out of the water on flash, and then we dropped the ball completely and screwed up. So let me sort of tell the story of that. There were 2 approaches originally with flash. Super expensive stuff. Do you make an all-flash array, or do you do what we did, which was use it as a cache technology to make the underlying disk faster? And we chose the cache approach. EMC chose the all-flash approach. And the sales results were clear. We were right, and they were wrong. And then came the part, we sold petabytes of flash. Then there came the part where we dropped the ball, right? And we didn't come out with an all-flash array, and we created an opening for, in the market, a lot of our loyal customers who needed something in that space tried competitors, and it was like, I'm sorry we did that to you. I feel like we're back now. I'm very pleased with the EF. I'm pleased with the all-flash FAS. We've been aggressive on pricing. We've got promotions on it. I feel like we've come back. That was an example of not predicting the future very well. Cloud. Cloud is both awesome and scary. I mean, if all you want to do is compute, it's especially awesome. And if all you want to do is compute for a little while, it's doubly especially awesome. I mean, I need 1,000 computers for the weekend. Amazon, turn them on, turn them off. HP won't take them back, it turns out. But where people get nervous, 3 big areas. Is the cloud safe? I put my data out there, can I get it back? And who else can see it? Is it legal? Is it even legal for the data to go to a particular place? I mean, just last week, the European Safe Harbor, these questions are still what's allowed? And finally, will I be locked in? So here's the common thread between all of those 3 themes. They're all about data. Data's what NetApp does. That's our home turf. So we ought to be able to help. And I mean, Joel gave a great demo yesterday of a whole bunch of ways we can help. The Alt-to-Vault, back up into the cloud. Or NPS, NetApp Private Storage, put your data right next to the cloud and maybe fail over from one cloud to another. Cloud ONTAP. I love the idea of Cloud ONTAP. ONTAP running in an Amazon data center. So there's so many ways that we can help, and NetApp's always been good at moving data from one place to another. That's a strength of ours. So I want to talk about what it's going to feel like. Because here's another tool that I use to predict the future. What's that saying? If you can't remember the history, you're doomed to repeat it. The trend, the historical analogy that I think is closest is the migration from Unix to Windows NT that happened in the mid-90s. There's got to be a few old people here. CIOs everywhere were saying, we are going to all Windows NT. I mean, literally, people were saying, in 3 years, there will be 0 Unix in my data center. And that triggered an enormous migration from Unix to Windows, which was followed shortly by an enormous migration back. Not because Windows was bad, it's just it wasn't all or nothing. Windows joined, we still have mainframes, we still have AS400, we still have Unix, we still have Windows, we still have Linux, but it joined the toolkit. Our vision is that cloud must join the toolkit. Not just one cloud, but multiple clouds. And so the question is, how do you make that super easy to have your data on-prem, have your data in a cloud, maybe move your data to a different cloud if that's where you want it? And for that, I'd like to do a demo with Joe Caradonna. Come on out here, Joe.
Hey, Dave.
Joe's been with NetApp forever. 17 years. That's a long time. He brought multiprocessor into ONTAP. You hoisted clustered ONTAP up on top of FreeBSD. You were the architect. Excuse me? FreeBSD up on top of clustered ONTAP.
Good times, good times.
You were the architect of software-defined storage. What do you do now? What's your title? What do you do?
So I'm the Senior Technical Director of a Data Fabric group. And my focus is on defining the technical agenda so we can realize and deliver on the promise of our Data Fabric vision.
Joe is the first person who ever mentioned the idea to me of running data ONTAP in an Amazon virtual machine. And I was like, oh my God, that would be really cool if we could pull that off. Where did that idea come from? What's the history of that?
Yeah, that idea was born from a journey that started about 10 years ago, where engineering needed a platform so we could scale our own development and test of data ONTAP itself. So we couldn't afford to give every engineer their own FAS system. So we engineered data ONTAP to run within a virtual machine. And then we built a massive virtualization farm to run it on. So today, at any given point in time, developers running over 4,000 instances of ONTAP on that system. And QA, they're running over 150,000 instances every single month. So that's where the idea was born. Customers started asking about, hey, I need that data ONTAP data management capability on my white box of commodity systems. So we took the concept and we launched Data ONTAP Edge. And Amazon was just a natural extension of that. As our customers are asking for, they were more interested in the cloud, Amazon in particular, we thought, they won't let us put our boxes in there, but what we can do is bring our operating system to their platform.
It's just another virtual machine, right? I mean, how hard could it be?
How hard could it be? And that's how Cloud ONTAP was born.
So here's the demo I want to do. If you remember yesterday, Nito and Jeff backed up Joel's awesome database into Joel's awesome backup, AltaVault sitting in the Amazon cloud. And so now the scenario is the data's sitting in Amazon in AltaVault format, and we want to get it to Azure. And you can imagine lots of reasons, like that was the general ledger, and now we suspect fraud, and we hired some data forensic accountant types, and so they like Azure. They like the Azure tool set. So we got to get the data from Amazon in AltaVault format into Azure. And so that's our mission. How are we going to do that?
Well, before we do this, it occurred to me that we've never really demonstrated product under development before here at Insight.
We are wimps.
Should we do this?
Our lawyers are like, no, don't demonstrate future stuff, but we talked them into it.
All right, so let's do it. All right, so here's what we're going to do. So we're going to use On-Command Cloud Manager. Now, this is our tool for managing public cloud resources.
You saw this yesterday a lot. Log in.
Yep, we're going to log right on into this platform here. And this is our workspace. This is where we actually create virtual machines to run in the cloud.
Empty.
It's empty. And one thing that's new is we're adding AltaVault integration to Cloud Manager. So that makes sense. And since Joel used AltaVault to back up into S3, well, we're going to have to create an AltaVault in Amazon to get it out. So let's do that.
So Joel used a virtual AltaVault. We'll use a real one. I mean, other way around. Joel used a real AltaVault. We'll use a virtual one.
So you name it.
One way or the other.
AVA on AWS, right? Joel's from the East Coast, so that's the region where he put his data in. That's what we're going to select here. And select our network configurations, credentials, and then we're going to plug in the bucket name, Joel's Awesome Backup. Get that in there. Typing slow. So here we are. Here's the summary.
So what's that checkbox?
Well, that little checkbox, just a little warning that the minute we hit this go button, Amazon's going to start charging you for resources. So let's spend some money on Amazon. Let's do that. So here we have AltaVault now in our workspace.
OK, so we need to get this data into a usable form in Azure. What are we going to do?
Now, you did say it had to be in a usable form. Yeah. So the way we're going to do this is, we've been working with Microsoft on this one. So what we're going to show you is we're going to launch Cloud ONTAP on Azure. All right. There we go. So there it is. Let's just select this, Cloud ONTAP on Azure. And one thing you'll notice here, if you've ever used Cloud ONTAP on Amazon, it looks exactly the same, how you set it up. So here, you select your data security policy. You could have no encryption, or you could have encryption. An interesting story about encryption. NetApp IT, they're an early adopter of NetApp products, as you might imagine.
Cynthia said yesterday, always cloud number one, our CIO, customer number one for ONTAP.
Yeah.
For all of our portfolio.
So they'll look at any new product that's about to ship, right, before it ships. They'll evaluate it. They'll evaluate different use cases and deploy. So they looked at Cloud ONTAP, very excited about it, dreamed up all these interesting use cases. But the problem is they couldn't use it for any of them. Because we have very strict data security policies for business data. And NetApp Legal shut it down.
So you just got to get the full story. Joe invents a product, and our own IT can't use it for anything. Does your mom know?
Well, now you know. But it's OK, happy ending. In the very next version, we realized we had to add encryption, and that's what we did. But not just encryption, because Amazon already had encryption services for EBS. What we needed to do is add the encryption, plus give you control of your key management and your own key management servers, and that's how we implemented it.
It turns out if you're encrypting in the cloud, it's bad practice to keep your keys in the cloud.
Some might say.
OK, let's move on.
We're going to move on.
Create a
So since this is Joel's data, yeah, we're going to decide to encrypt it here. Again, East Coast. Select our network. Credentials. Now here we're going to select Azure's premium storage. That's the good stuff. So our summary, again, you get the click box. We're going to spend money with Microsoft. Yeah? Do it, Microsoft. So here we have two clouds in our workspace, right? We have our AltaVault sitting in Amazon. That's where our data lives now. And we have Cloud ONTAP running in Azure.
Now, there's a lot going on in this picture. 2 different data centers, 2 different hyperscaler companies, 2 different storage operating systems with 2 different data formats. How would you get the data from the first to the left, to the next?
I'm going to show you right now. We're going to drag this cloud on top of that cloud. All right.
Apple introduced the first drag-and-drop consumer product in 1984. And in 2015, NetApp demoed drag-and-drop.
OK, all right, that's fair. That's fair. We'll get into what's going on under the covers in a moment. But one thing I want to point out is it's not just drag and drop. Everything you can do in Cloud Manager has a RESTful API, every operation. So this is all programmatic. All right, let's move on. We're going to select Joel's awesome volume, because that's where his awesome database resides and his awesome backup. Select our snapshot. This is what we're going to restore. And then just, once again, summary screen. We're just going to go right ahead here and hit that go button. And we are
Now there's a line. That's cool. Oh, you can see it up there.
Yeah. We've established.
Can you show me the data
relationship.
moving?
Yeah, let's do that. So the data is actually being transferred from one cloud to the other. Let's show that data transfer.
So suppose you didn't have the drag and drop. Tell me what things would have had to happen in order to make that thing happen.
Yeah, well, what's happening here under the covers with that drag and drop, it's really automation of Snap Mirror, or in this case, it's actually Snap Vault between AltaVault and Cloud ONTAP. So we're bringing.
I don't know if you picked up on that. The Snap Mirror protocol now runs in AltaVault.
And we're not going to stop there. We're bringing Snap Mirror across the entire product line. So this is how we're building a data fabric. Looks like the data transfer is complete, Dave. Now let's take a look. Let's look in that Cloud ONTAP appliance. Click in here. Let's make sure the data is there.
My favorite demos have a whole bunch of stuff that happens, but you don't do very much. Because isn't that what we all want, to not do very much?
And there it is. If you're looking real closely, we got 10 gigabyte database transferred. We're in Azure, ready to be used.
So I kept interrupting you. Why don't you just show me that thing again?
All right, you guys want to see it again? Let's do it. 1984. Drag and drop. This is the foundation of data fabric, these kinds of technologies.
So this looks suspiciously like a video. What part of this is actually real, Joe?
This is, in fact, a video. All the technologies that you see here, we can do in the lab today.
So what I just noticed that we did, we made it super easy to spray your data anywhere you want it in the world. Isn't that dangerous?
Only if there's drones. So yes, we talked about security. We talked about some of our own challenges there. We've added encryption to Cloud ONTAP. We have encryption in AltaVault. We have encryption across our storage arrays. But true data security doesn't stop there. To truly have data security, you need visibility and control into your data. You need to know where in the world it is. You need to know what state it's in. And you need the tools to enable you to do that, to be able to tag it properly and track it and apply policy and then enforce policy. And these are the kinds of things that you could expect us to deliver to you as we evolve our data fabric.
These are the things we can't demo right now. So I want to ask you something, Joe. You've been on a journey. I mean, you've been a programmer at NetApp for ages, doing the sort of traditional C, I own a box thing. And now for the past few years, you've been in this virtual cloud world. Like, what have you learned? What does it feel like in that new place?
So it's interesting. I mean, the cloud, for one, it's a moving target, right? But it's also a target that can move very quickly. And what we had to do is we had to evolve our engineering processes and adapt so we can keep pace with the change. And we've done just that. At Insight last year, George announced Cloud ONTAP. And here we are a year later. We've had 2 releases since then, and we've got a 3rd one coming out soon.
So that's about triple the release rate of the hardware ONTAP.
Right. It's not an 18-month release cycle. So, also, AltaVault released a year ago. You look at that platform today, everything about that platform is different, even the name, right? OpenStack, it's a very active community, and they've put out a release every 6 months, and we're right there with them.
You had a stat about how much code we'd contributed to the OpenStack releases. I'd love for you to share that with the audience.
Yeah, you know, this is the latest release of OpenStack, the Liberty release. NetApp submitted the most code out of any vendor for both Cinder and Manila.
I thought that was awesome.
Yeah. So, you know, we showed you guys one demo here of the future, right? But there's more. There's more to see, and there's more to see today, in fact. You know, we had several teams throughout engineering, developing a bunch of different demos for all of you to see. And how many people do we have here? 6,000 people, something like that?
5 or 6. give
Now,
or take?
I'd like to invite all 6,000 of you to go to the booth after this, right? So you can go see those demos. Let's create a line. And they're showing you what we're working on and how we're going to be enabling the data ONTAP, well, the data fabric going forward.
So go see the demos. Joe, thank you so much for demoing this stuff.
All right,
I love
thank you.
this company.
Thank you.
So when we have tools like that make it easy to put stuff in different places, different clouds, on-prem or NPS near, how's it going to play out? What cloud should I use? Where should I put my data? One interesting way to think about this is actually to think about the application development lifecycle. So if you think about that, there's the phase where we're inventing a brand new app, and oh, look, my God, it might actually work. Let's deploy it. Maybe someday it starts to grow. And then eventually it's yeah, we're going to use this app for the next 10 years. These 3 phases. That first phase, we're developing a new app. These days, not 100%, but very common to say, that should be born in the cloud. And even if it wasn't exactly born in the cloud, let me tell you the use case that a Cloud ONTAP customer that I met, just ran into the guy. He swiped it on the credit card. He was at Insight last year and said, well, that's cool. And he had a web development team, and they wanted to move on to Amazon. So he said, you know what? To keep our arms around the data, I'm going to fire up Cloud ONTAP, snap mirror the web team's data into Amazon. For a while, they just did test and dev there, brought it home, and launched it, and then, well, we could do production out there as well. The next stage, it's a gaming company, and if you know anything about programmers, anybody know a programmer? They can be hard to control. Imagine the programmers who develop video games. So they're already putting their data out in the cloud and doing stuff, but how can you bring it back home? So it's an awesome place to start, but it can get scary when you're using a cloud provider. When you look at what's the best cloud to get started in, Amazon and Azure, both very flexible, turn it on, turn it off, no commitment, no, how long do you want it? Everything is easy, good tools for getting going, good development tools, fast evolving development environments, but it can be a complicated billing model. We had a customer, a software as a service customer in Australia. They got to the point with Amazon that they were doing 50,000 cloud APIs per hour, and their monthly bills had 25 million lines. So how do you even process a bill like that? Well, what you do is you fire up an instance of Amazon Data Analytics. And so when you start to get into this growing phase, oh, it's gone. When you start to get into that middle growing phase, there's a lot of other considerations than just how quick is it to develop. You might want a different billing model, a more stable billing model. You might want more of an enterprise relationship, a company that knows you and knows your business. And so cloud providers like telcos, or like regional cloud providers, or maybe one that's vertically focused on your specific industry might make more sense. So it starts to make a lot of sense to think about other alternatives, but now we're back to the question of how do we move the data. The point here is this is not a one-way trip into the cloud, and it's not even a one-way trip to one particular cloud. It's into the cloud and over to a different cloud. And then when you get this stable, mature, we're going to own this for the next 5 years, this is how we manage our customers or do our ERP or whatever, it might make sense, depending on the size of company that you are, to bring it back home, back on-prem, or possibly hosting. So there's different solutions in different parts of the life cycle. There's also the question of, where should I put my data? And that doesn't have to be the same answer as what cloud should I use. When the data's small, the demo we just showed, we can easily take a small database and we can drag and drop it to a different place. We can solve the UI issue. What we can't do is we can't solve the physics issue. And let me make the physics issue just really clear to people. We had a customer that was in a hyperscaler cloud. They had 9 petabytes in the hyperscaler cloud, and they started scoping out the project to get it out. Based on the bandwidth that they thought was reasonable to pay for, it was going to take 3 months to get the data out. And the bill was $600,000 per month. Now, I don't want to say that that was a bad deal for them. It may well be that they were raising money and they could avoid a big capital expense before they went public to raise their funds, right? I mean, it may well have been an awesome deal. My point is, you want to be really careful where you let data pile up. And putting data next to the cloud, remember the demo yesterday where how long does it take to fail over from Amazon to Azure? 5 seconds. No matter how much data is sitting next to the cloud, you can do a failover from Amazon to Azure. You know, they mentioned, hey, you might do that for quality of service reasons. Here's another reason you might do that. At the beginning of every week, you might say, Amazon, Azure, soft layer, what's your price quote for the week? Oh, good, I'll run it there. That's a kind of control that you could never have if your data was living in the cloud. So I originally described NetApp Private Storage as maybe if you're afraid to get to the cloud, you can live near the cloud. It may well be for big chunks of data, that's the right permanent place for it to live. I'm going to completely switch gears. I have an odd relationship with NetApp. People are always asking me questions like, why are you still here? Or what do you do? Or sometimes, what does it feel like to have built? Like I was in the show floor last night. What does it feel like? Look what you built. Anybody here have kids? Did you build them? Can you control them? I feel that way about, like a parent. I mean, NetApp's my kid, but most of NetApp is people who were hired by people who were hired by people I maybe never met. So, you know, you think about what constitutes a good relationship between a parent and a child. I'm just happy NetApp will still talk to me. Sometimes it even listens to me. But not all. Another reason that I think we're in a fun place. Data, so I have to say, when we started, 1992, data was boring. Right? I mean, data was the schematics for clock radios or, you know, whatever. It was mostly nerdy engineering. I mean, maybe some of us thought it was interesting, but try explaining data to your mom if she wasn't a clock radio engineer. But now data is like, it's so close to home. I mean, not all of it, but it's like we were holding the data that discovered the God particle at CERN, which is like super scientific, and we do data for movie special effects, so like The Hobbit, which is just cool, or love letters, or a movie of your baby's first steps, or the stuff at the hospital looks at to figure out what to inject you with when you show up unconscious. I mean, data is in the center of our lives, and that's what we're helping people with. So it just feels like we're in a really, really cool spot. I think that's fun. And it's not just data in general. When I look at the cloud, remember the compute part of the cloud was the easy part. Got a computer, stop my computer. Got another computer, different cloud. It's the data part that's hard. I really believe that data is the key to the cloud, and that puts us right in the spot to help. And so I want to share a final tip about how you predict the future. And that final tip is based on the science fiction writer William Gibson. And not everyone here may have heard of William Gibson, but you've all heard of some of the things he predicted. He was the guy who invented the term cyberspace, long before the internet. The future is already here. It's just not very evenly distributed. And if you think about that, what does that mean? Whatever thing is going to be the future a lot in 5 years, it's probably already happening a little bit today. That's the not very evenly distributed part. Some crazy person right now is already doing the future. And that does not mean that you just look at anything a crazy person is doing and copy that. But it does mean if you want to get more hints, because that's all, we don't know the answer, right? But if you want to get more hints about the future, looking at what things people are doing that just feels out of the ordinary, that's a big part of what I've tried to show you in this talk. I mean, the future's not very evenly distributed. We can do stuff in the lab that you can't buy, right? But that's the future. Another technique we use is to look for customers doing the most interesting, innovative things and try to figure out what are they doing, and let's talk with them about what other stuff they might want to be doing. And can we show our other customers, when you go look at the breakout sessions, that the whole construction of Insight, to some extent, is around how do we find that unevenly distributed part of the future and bring it here to other people so they can get a hint of what the future might be like. So it's complicated what stance a company like us should take. A lot of times customers ask me, should we move into the cloud? And here's the answer I give most frequently, and you can quote me on this. I don't know. I don't know your risk tolerance. I don't know your profitability issues. I don't know what your competitors are doing. I don't know, understand your technology well enough. But even though I don't know what our customers should be doing, we're happy to talk about what other customers have done, what seems to be working, what's not working. Even though I don't know what our customers should be doing, I know what NetApp should be doing. There's two approaches with something like this. One approach is to drag your feet. Whoa, that cloud's looking pretty scary. Better buy another E-series system. And the other approach is to run at it as fast as we can, even though we don't know all of the future and we're not sure how the whole thing's going to work out, run at it as fast as we can. And here's why we have to do the second one. Because it's clear what direction things are going. Now, it's not all going into the cloud all at once anytime soon. I really believe this toolkit model, there's still going to be mainframes along with it, but shrinking. The cloud will be the growing part along with our Linux and Unix and Windows and AS400s. But people are moving that direction, and they have to believe that NetApp is actually going to help them go there. If you don't believe that, you won't even talk to us as you're doing it. Or if you're a partner of ours, if your customers don't believe you will help them when they're ready and it's their time, you won't find out. And I really do believe we can help. And I have this theory that if you take really hard problems that customers want to solve and you figure out how to solve them with them, somehow in the end you'll figure out how to get paid for it. Right? This is not like a super businessy thing, but it's kept playing out that way. And so that's the approach that we are taking. We absolutely are pushing towards the cloud, how to be more in the cloud, how to get the data into the cloud, how to bring it back later. And I believe that if we can help you do that, we can all win together. Thank you so much.
All right. Well, I was back there, and I could see the demo back there, and two words came to mind. The first one was, holy, and the second one, I can't say because I'm not a founder. It's fantastic, though. So just a quick recap of what we've done in the general sessions over 3 days. George and Rob, they spoke about us, NetApp, being a mature company with the energy of a startup. I hope you've witnessed some of that this week. Our partners that came up on stage shared how they're engaged with our vision and see the value of data fabric. And then we saw some amazing demos, and it's so great to see how excited people were and hearing the ovation for the demos. And then, of course, we had fantastic visionary pitches from Chris Anderson and Dave Hitz. I think they did a super job. There's a long list of people, if you think about this type of event, there's a long list of people to thank across all through NetApp and our vendors. Just a tremendous amount of hard work. So I'm not going to put up lists. You always risk that the piece where you might forget somebody, so we don't want to do that. But everybody who's been involved in putting this event together, you know who you are, and I'd like for everybody to give a big round of applause for them. For our customers who are here, I hope you leave with an understanding of the heart and soul that everybody in NetApp, through our execs, all the way down across our partners, put into this event. It means an awful lot to us for this to be something special for you. And then I already hope you leave here, or before you leave, like maybe right now, you're thinking of ways to build NetApp Data Fabric, and then you're going to reach out to us and our partners to help you. So for me, it's been a big honor hosting the general sessions, just super proud of what we've been able to accomplish. But now, it's time to party. please grab your wristband, join us down at the Mandalay Pool for the attendee appreciation dinner, and we're going to see Train. Thank you, everybody, and we'll see you next year.